Good morning. Hope you're doing well. This is going to be the video for 5.4, which is the triangle inequality theorem. Okay, so the triangle inequality theorem, all right, is an important theorem for building triangles, all right? And the triangle inequality theorem says, so let's just write this out. It says the sum of the length of any two sides of a triangle, of course, is greater than the length of the third side. And this is important not just for this, but it has applications even higher. Essentially, this is the theorem that says the shortest distance between any 2 points is a straight line, okay? So I just want to draw for a second. If we think about, it says write 3 lengths that would be impossible to use for side lengths of a triangle. If we think about side lengths like 1, 3, and 10, right? If we think about those side lengths, clearly 1 plus 3 is less than 10, right? And so if we tried to make this triangle, first of all, let's just draw a random triangle, right? This clearly isn't 1, 3, 10, but let's say if this was 1, 3, 10, all right, this is what I was talking about between the shortest distance between 2 points. If we had points here, okay, the distance straight there is 10, but then you can go off to the side to the left, and then you can go over to the right, and that distance is only 4, right? It doesn't make sense. So if you think about actual, lengths, if this is 10, right? And then we have 1 over there, and then we have 3, those can't make a triangle, right? The 2 small sides aren't going to touch. The third side's too big, okay? So that's kind of what we're looking at. So you can kind of tell, if 3 side lengths could make a triangle by just taking the smallest 2 and adding them up, right? And then that's bigger than the third side, so yes, right? That would make a triangle. If we looked here, right, 2, 4, and 17, 2 plus 4 is only 6, right? And 6 is way less than 17. So this is going to be no, okay? That's not going to be a triangle. 3, 5, and the square root of 9. Okay, well, the square root of 9 is 3, right? So the 2 smallest sides are 3 and 3. So 3 plus 3 equals 6. 6 is greater than 5. So we can say yes. All right, that is a triangle. The other thing, right, it doesn't really, okay. There's not really a place where we're writing this down, but the other thing to do with the triangle inequality is that maybe we've kind of been building to this, but bigger sides are across from bigger angles, and smaller sides are across from smaller angles, right? So we were in 5.3, we were talking about the base angles theorem, right, where if 2 sides were the same, the angles were the same. Well, if you make the side bigger, right, if you make the side bigger, then the angle there has to get bigger, okay? And because of that, you can kind of order things based on what you have. So our smallest angle, so it wants us to list things from smallest to greatest. Our smallest angle is C at 51 degrees. So our smallest side is AB. Then our next angle is A. So the side across from that is CB. So that'd be our next smallest side. And then our biggest angle is B. So then AC would be our biggest side. So you can kind of do that, and you can do it with sides or angles going either way, right? Like we got 6, 9, 10. So what's across from 6? So S would be the smallest angle. 9 is the next smallest side, so that'd be angle R. And then the biggest side is 10, so that would be angle T. Here, we don't actually have the third angle, but you can get it. So what's 29 plus 127? That's 147, 156. So that would only be 24 degrees. So that's actually the smallest angle. So the smallest side is going to be NP. And then we've got P the next, so that's going to be MN. And then we've got N, so that'd be MP as the biggest side. Okay. The next one. If a triangle has angles that are 25, 72, and 83, give 2 classifications that describe it. So if you think of the classifications we have based on angles and sides, so all 3 of these are less than 90, so we know this triangle is going to be acute. And then all 3 are different, so we know the triangle has to be scalene. If a triangle has angles that are 35 and 35, give 2 classifications about it. Well, 35 plus 35 is 70, so the third angle has got to be 110. So that means this triangle is obtuse. And then since 2 of the angles are the same, we know it has to be isosceles, okay? And gosh, there are a lot of questions on this. Let's keep going. Suppose a triangle has side lengths of x, 2, and 6. Draw a picture of each extreme of this triangle. Okay, so this is the big part, right? So when it says extreme, it means the low end or the high end, okay? So if we look at this triangle, what's the lowest it could be? So the lowest it could be would be whatever number makes these 2, since 2 is less than 6, makes it equal to 6. So that would have to be 4, right? Do they want it to be like, I don't even know. So that'd be like 2, 4, and 6, right? On the upper end, what if it was the biggest side, right? Which means the other 2 sides have to add up to it. Actually, this isn't correct. It would have to be like 4.1 because it has to be bigger than the other side. I mean, that's the thing. How do you get there? It could be 4.1. What about 4.01? That's smaller, 4.001. So, it's kind of complicated. If we wanted it to be the biggest side, what would that have to be, right? 2 plus 6 is 8, so it has to be whatever is the first number less than 8. So what is that? We've got like 2, 6, so like what, 7.9? But what if it could also be 7.99 or 7.999? So you see that you can't really write down the biggest extreme because, numbers are infinite. So there's always another number, right? There's always another 9 that we could add. So that's why we can write inequalities, right? Write a compound inequality to represent all the possible values for x. So we know it has to be bigger than 4, right? So it has to be greater than 4. That's our greater than sign. But it also has to be less than 8, right? So we're looking at the 2 extremes, not or equal to, just greater than. So 4.000001, but there could be another 0 in there. So you can kind of do that. Just kind of look at the smallest and the biggest. So given 2 sides, write an inequality, draw diagrams and triangles to illustrate your reasoning and support your answer. We're not going to do that. So what would the smallest number be, right? What makes the smaller side add up to the bigger side? Well, that's 5, right? So we know it's got to be bigger than 5. But then if we add these two numbers together, we get 15. So it has to be less than 15, right? And so I don't think this is that hard, but students have trouble with it. You're just looking at what's the difference here, right? 17 minus 7 is 10. So it's got to be bigger than 10 because 10 isn't big enough. But on the opposite end, then you also want to look at the sum, which is 24. So it's got to be less than 24 because if it hits 24, then right, these two numbers aren't big enough to reach it. So you're kind of just doing this. What's the difference? 5, so it's got to be bigger than 1. And then 6 plus 5 is 11, so it's got to be less than 11. Draw diagrams, or I don't know. Are these diagrams? Whatever. Okay, let's finish this up. So in PQR, PQ is 8, QR is 7, RP is 15. What is the largest angle of the triangle? Well, what's the largest side? The largest side is RP, so the largest angle has got to be angle Q because that's the only angle that's not in the side. Could lengths 13, 11, and 5 represent the lengths of the sides of a triangle? Well, let's look at the two smallest numbers. That's 11 and 5. 11 plus 5 is 16. 16 is greater than 13. So we're good. So yes. A triangle has lengths 38 and 55. Give 3 possible lengths for the third side. Well, if we think about it, it has to be less than, what's 58.5 minus 38? Or sorry, greater than. That's going to be what, 17? So it's got to be greater than 17, but it's got to be less than 85, 93. So literally you could say any numbers in between 17 and 93. So 25, 32, 45, Give 3 lengths that could not represent the third side. So anything less than 17, so we could say 15. Anything greater than 93, so we could say 100, and then we just got to say a third one, 105. Okay. So I kind of went through this quickly. There was a lot of them. If you have questions, you can always message me and let me know. The homework, the practice is very similar to this. So just kind of look at it. If you have any questions, let me know, and have a great day.